Right. So just like we did with confidence intervals, we had means and then we had proportions. And proportion was different from mean, right? We weren't measuring things within the population. We were looking at individuals in the population and asking, do you belong to this group or do you have this characteristic or not? So let's do some examples of these. The math is a little bit different and the calculator setup's a little bit different, but it's actually easier. So I want to know if more than half of Americans plan to vote. So I survey 100 people, and 53 say that they do plan to vote. Okay, so let's look at our numbers here. The proportion I'm comparing to is 50, or 0.50. Okay, so that's my P naught. That's the number that I'm comparing to. And I want to see if it's higher. So my alternate hypothesis is that the actual proportion will be greater than 50. The number of people I surveyed was 100. So there's my N. And the number of yeses, the number of people in the group that I'm looking at, people who plan to vote, was 53. Okay, so just like with confidence intervals, this is a little bit easier, a little bit less information to type in. So let's look at where we go. Stat, over to test, and then we're looking at a one proportion z-test. Okay, and these are the only three we're going to use, z-test and t-test, which we've done for a couple of videos already. And then we're looking at a one proposition z-test. And not very much information. What's the number we're comparing to? That's our P naught, that's 0.5. And then how many successes, right? How many yeses, how many have that characteristic out of how many in the sample? And then the type of test. I'm just trying to show that more than half, so I want to say that the actual proportion is greater than the P naught, the number we're comparing to, and I calculate. And I get my P value. Okay, there's a lot of P's going on here. P hat, that's the actual proportion from my sample. That's kind of like X bar. 53 out of 100 is 53% or 0.53. It's doing that math for us. We don't really need it done, but it did. Z is 0.6. I don't really even have any idea what Z is. It doesn't matter. But the value for P, our level of doubt, is 0.27. Now that's too much doubt for any of those bars that we set before. We talked about 10% or 5% or 1%. We got 20%, 27% doubt. That's an awful lot. So we would fail to reject the null hypothesis, meaning I'm trying to show that more than half, but this is not good enough evidence that more than half are going to vote. So I can't say that it's not half. I can't say that it's more than half. I fail to reject the null hypothesis. Let's look at one more. Doctors claim that 20% of the population have a particular genetic condition. You always run into genetic condition word problems in these sections. I want to see if their claim is true. Okay, doctors claim 20% have the condition. I want to see if their claim is correct. So I test 60 people and find that 11 have the condition. So this time, the claim for the proportion is 20%. I'm curious if that's correct. I'm not saying it's high or low, so this is going to be not equal to. We test 60 people and find that 11 of them have the condition. All right. There's no distinction with P or T here. With Z or T. One prop Z test. My proportion of interest is 0.2. My X is 11 out of 60. And it's a two-tailed test. I'm just curious if it's right, not if it's high or low. And then we calculate. And here we get, wow, p hat is 18% in our population. So we didn't figure out the percentage here, but 11 out of 60 constitutes about 18%, which is not that far from 20. But we have a p of 0.746. So we get 75% doubt here, which is way too high because we weren't very far off from the number, right? 18% is very, very close to 20%, so it's nowhere near far enough away to be convincing. I want to run that again, and I want to change a number. Let's say that we had surveyed 60 people and only 10 of them had had the genetic condition. How does that affect our results? Still not that great. That knocks us down to 16% of our sample had the condition. We still got over 50% doubt. Okay, that's how to use the proportion test, the 1-prop Z test. And one more video to go for this, and we'll wrap it all up.